Welcome to another day on the Journey Chez Chem. Well, today's warm-up is a data table very similar to what you're going to be doing in the lab tomorrow. So please do it to the best of your ability. And it also is very similar to the homework problems that you had in number 2 and number 3. And I'll see you in a moment. Number 1, we are determining the heat that is gained by the water in the system. And we are going to be using the equation that we used yesterday, which is that heat gained equals heat lost. And the heat is going to be gained by the water. And the heat that is lost is by the metal. Now we know that heat equals mass times change in temperature times the specific heat capacity. And therefore that goes on both sides of the equation. The mass of the water times the change in temperature of the water times the specific heat of the water equals the mass of the metal, the change in temperature of the metal, and the specific heat of the metal. Now I will rearrange this equation to solve for my one thing that I'm looking for, which is the specific heat of the metal. Therefore, to undo this multiplication, I will divide. So I have the mass of the water, the change in temperature of the water, the specific heat of the water divided by the mass of the metal, the change in temperature of the metal, will be equal to the specific heat of the metal. Now, I know that these values are all going to be found in the data that has been given. The mass of the water, well, I am going to have to subtract the cup from the water and cup. And therefore, that mass is going to be 75 grams. The change in temperature of the water is that once I dropped it into the styrofoam cup, its new temperature of the system is 24 degrees Celsius. So it went from 22 to 24 degrees Celsius. So the change in temperature is 2 degrees Celsius. And we know the specific heat capacity of water is 4.18 joules per gram degree Celsius. That is the answer to number 1. And that works out to be 627 joules. Now, because I'm going to use this in my next problem, 627, oh, I inverted those. I know you do that too sometimes. 627 joules is my heat that was gained by the water. Now I am going to divide it by the mass of the metal, which is 67.5 grams. And the change in temperature of the metal, we had that metal in boiling water. And the water's temperature was 96 degrees, and it changed to the final system of 24 degrees Celsius. And that would be 72 degrees Celsius. When I do all this math, I will end up with 0.129 joules per gram degree Celsius. And it was exactly 0.1290. And I want to take my specific heat capacities 3 places past the decimal. So my final answer is 0.129 joules per gram degree Celsius. And this is exactly what you'll do tomorrow. Now, once you determine experimentally what your values of those metals are, then you will look up the theoretical value and get a % error. And we'll talk about that more after the lab. Now, I need to talk to you about limiting reagents, so please go over the answers to worksheet C with your facilitator, and then come back, and I need to discuss a few of the things on worksheet D with you. This concept is about limiting reagents. And I'm going to go through number 1 on worksheet D with you and find the answers that we're looking for. And then I'm going to discuss an analogy that might help you understand it as well. Some students it helps, and some students, they get more confused. But give it a shot and see which way helps you. But by practicing it, you'll understand it better. Now, the way that I handle this is that I always go to the first one that I am working with. And my recipe is my balanced equation. So in my recipe, I have 1A, and 1 is to 1 mole. 1 is to 1 mole, as 2 is to X. I am ignoring the fact that I actually have 1 mole here. I want to determine how many moles would be required to use up this 1 mole that I have for A. And when I do the math here, so the recipe numbers for the coefficients are in the top, and then what I have is in the bottom. And when I solve this, I find that X is equal to 2. However, I only have 1 mole and not 2 moles. So I'm going to run out of B. So B is going to be my limiting, and A will be in excess. And whenever I do mathematical calculations to determine how much is produced, I always have to use what's going to run out, because that is what is going to stop the reaction from happening. So I then use my limiting reagent, and I say I have 1 mole of B, and the mole ratio is that there are 3 moles of C for every 2 moles of B. I use the molar ratio in the balanced equation, and therefore I will produce 1.5 moles of C. I always have to base what I can produce on my limiting reagent. So let's talk about this as though it was a recipe. And what I'm making here are cupcakes. I'm going to make cupcakes. So C stands for my cupcakes. And this is my recipe, and it calls for 1 cup of flour and 2 eggs. That is my recipe. And I actually have 1 cup of flour and 1 egg. I'm like Mother Hubbard, and that's what I have in my cupboard. I have 1 cup of flour in the house, and I have 1 egg. That's what I have to make these cupcakes. So I want to determine, well, my recipe calls for 1, and I have 1 cup of flour. And the recipe calls for 2 eggs, and I want to find out how many eggs would be, it would take to use up the 1 cup of flour in this recipe. I cross multiply, and I get 2 eggs is how much I'm going to need. So I'm going to run out of eggs. I only have 1 egg, not 2 eggs. The recipe calls for 2 eggs, not 1 egg. And I only have 1 egg. So I can only make the amount of the recipe that will be allowed by that 1 egg. So any amount of the recipe or anything in here is all going to depend on what I run out of. Now, I would then say I have 1 egg, and there are 3 cupcakes for every 2 eggs. And that would mean that I could only make 1.5 cupcakes with the amount of materials that I have. This is what I have in the house. I only have 1 egg. So I have to base the recipe of how much I can make on the eggs. Also, I can say 1 egg is what I have, and I want to know how much of the flour it's going to be able to use. So there's 1 cup of flour for every 2 eggs. Therefore, I'm going to have 1/2 of the cup of flour. In order to use that 1 egg, would require 1/2 cup of the flour. So you can see that the limiting reagent is like in a recipe, the things that I have, this is what I have, and it's going to determine how much I can make. And everything in the recipe depends on that limiting reagent. So let's try another one of the homework problems. I'm going to do the second one in number 1. I have 2 moles and 2 moles. Again, I first have to figure out what I'm going to run out of. 1 is to 2 as 2 is to x. I'm ignoring the fact that I have 2 moles there. I want to know how many moles it would take to use up these 2 moles of A. And as it turns out, I would need 4 moles of B, but I only have 2 moles. So again, the limiting reagent in this case is B, and the excess is A. Now, to determine how much of C I can make, I use the 2 moles of B, and there are 3 moles of C for every 2 moles of B. And therefore, I'm going to get 3 moles of C that can be produced. Now, just because in both cases B was our limiting reagent does not mean that B is always going to be the limiting reagent. You have to work out the problem. And also, you don't go by which is the larger number. That's why in both cases I had the same amounts of each one of the compounds, and I had to determine which was limiting. So let's try one more. I want to try number 5. And we'll do 5 and the last one. The reaction is that 2A plus 3B gives C plus 5D. Now, I want to use the one where I have 5 moles and 10 moles. I go about it the same way, and this is number 5. 2 is to 5 as 3 is to x. 2x equals 15. Therefore, x is equal to 7.5. And I have 10 moles, so I have more than what I need. In order to use up these 5 moles, I need 7.5 moles of B, and I have 10 moles of B. So I have more than enough of B. So in this case, A is my limiting, and B is in excess. And so to determine, so this is what I must do first, is to figure out which one's going to run out, because that determines how much can be produced. And therefore, A is limiting, so I say that I have 5 moles of A, and I want to find out C. There's 1 mole of C for every 2 moles of A. Therefore, the amount of C is going to be 2.5 moles of C. Because 5 halves is 2.5. I have 5 moles of A, that is my limiting reagent, and there are 5 moles of D for every 2 moles of A. And 5 times 5 is 25, divided by 2 is 12.5. Therefore, I'm going to get 12.5 moles of D. So I hope that helps you to understand what limiting reagents are all about. They are a bit challenging, but I know you're up for the challenge, and we had so much fun today, and I can't wait to see you tomorrow.